Om Namah Shivaya. Very good evening to all the participants join this today's discussion. I hope all are fine. So today, as you know well, this week we will be discussing this Internet of Things and its application. Since this Internet of Things is one of the emerging area, and it will be creating a lot of job opportunities and for the future engineers. So this one of the focus to taken by the to talk today's talk. Moreover, this in this talk we will be covering what is basic of this Internet of Things as well as the applications and how this opportunity are there in the field of IoT for the future engineers. So these points will be covered in this today's presentation. I request participants can listen this presentation. Then we'll go for the question and answer session. Thank you. Today, the contents of the presentation from introduction, followed by history of IoT. Before going to do the contents, let me introduce myself. I'm Dr. Lakshmanan SA, working as assistant professor in the Department of ECE, Amrita School of Engineering, Chennai campus. Yeah, thank you. So the contents of the presentation, introduction, history of IoT. That means the IoT is now we are talking about this IoT recent years, but which is the platform to create this IoT and when it has been started, followed by the basic structure of IoT. I'll be discussing this history, structure and all, some different point compared to the previous sessions, right? And also the characteristics of the IoT, what are the main characteristics of the IoT and how can we understand the characteristics to implement in the practical systems, followed by IoT as an industry and future perspective, what the industry is expecting in the area of IoT, followed by how we can differentiate the IoT with respect to the future perspective. So these points will be covered in this today's presentation, and then the technology roadmap. The technology roadmap in the sense from the 2000 to 2020, including now 2020-21, what are the various technologies happened in the field of IoT that will be covered in this today's section. Then applications. What are the various applications in the field of IoT and the opportunities for the future engineers in the field of IoT. So that will be covered. Then industrial IoT. Mainly this slide focus on the IoT plays a major role in industry. That means operation, maintenance as well as production, all those areas. So industrial IoT will be discussed in conclusions. Okay, as you know well, IoT, Internet of Things actually. So what is basically IoT? Exchange the data between the objects and which leads for some action. Basically, the IoT refers to things which are connected to the internet. So this plays a major role in the field of Internet of Things, right? So the IoT is a network actually, or physical devices or things embedded with various equipments like electronics, software, sensors, with the internet connectivity, which enables those objects to collect and exchange the data. Basically, it's a dynamic global network. It's not a static network. It's a dynamic global network infrastructure with some self-configuring capabilities. That means it has to be understand the problem as well as providing the solution accordingly. So it's a dynamic global network infrastructure with a self-configuring capability based on the standard communication protocols. Yes, we have to follow the standard communication protocols in this IoT system, in which the physical as well as virtual things are interconnected and use these intelligent interfaces. That means using these computational techniques, artificial intelligence techniques. So using that intelligent interfaces that to integrated with the information network. See, this IoT is covering various areas. That means it's covering information network, intelligent interfaces network, as well as the physical and virtual things which are connected together in this to perform the operation. That means it's one of the emerging area which will be useful for various applications in the future. That's what is generally referred as the things which are connected to the internet. Basically, the IoT allows the objects to be sensed and controlled remotely. Because suppose you take a power system, we are very far away located from the power generation system, right? So once we implement this kind of IoT technology, So the data can be sensed and then controlled remotely across the existing network infrastructure. That's the motivation of this using this IoT. And also this IoT creating opportunities between the physical world and computer-based systems. What's happening there? So such that the efficiency can be improved further and accuracy is improved, as well as it will provide a lot of economic benefits. That's what the researchers are trying to move this use of these IoT applications to all the areas, including smart grid, smart power systems, as well as electronic side, medical electronic side, and most of the research areas. Okay, so basically, this IoT used to collect the useful data with the help of various existing technologies. That means, what is existing technology means? Using this RFID or some other protocol systems can collect the data and then extend the data, and then that it will execute the operation to proceed further. The history, basically the IoT now we are talking, especially this last 2010 onwards is one of the emerging area. Now we are mostly working on this area. But the idea came to the implement this IoT from 1832 itself. That means starting from electromagnetic telegraph, followed by they were working with telephone. Then after that in 1960s and all, the information system started developing, right? Because of the development in the field of semiconductors and computers. So 1964, the beginning of information systems followed, and then we also have this protocols. That means TCP, transmission control protocol, and internet protocol systems are they started developing from 1970s onwards. So that are the background for developing this IoT. Moreover, in 1991, first web page, then followed by 1999, we have this IoT is officially named actually as Internet of Things like that. Then the implementation of this GSM GPS technology, that example global system for mobile as well as the global positioning system and Wi-Fi is all very basic fundamental to develop this Internet of Things. And in 2005, you know very well, a lot of open source electronics came, like example Arduino and all. Okay, so they're all very much useful to develop this Internet of Things. And 2012 onwards, global level standards are initiated to implement this IoT for various applications. And then this 2012 is a very important stage actually. RFID came, that is radio frequency identification came. So from the starting of this RFID, the IoT came into the application side. The researchers are working very keenly. And 2019, the trends of future that is working with IoT, and 2020-21, a lot of researchers are continuing, and it's slowly involving everyone life. That means we have to understand this IoT very clearly. That means the history, we have discussed that from the starting of this 1832 implement of this telephone and all, and now we are in the end of this IoT. So we have to understand this further. And basically, how this IoT works, basically Internet of Things. As we know that many cases, the many technical developments and capabilities that taken together to help to bridge the gap between the world, virtual and physical world. How means that it depends upon the communication and the cooperation we are using, that is using the communication system, as well as the addressability. That means how we are taking this IoT to address the various problems, as well as identification. That is one of the very important. Then sensing. Actually, you know well, the sensors placing the major role because we have to sense the signal in which we are implementing this IoT, followed by this actuation. For example, if you use this electrical actuator, the signal can be converted to electrical signals. So then embedded information processing. This is one of the very important stage because of the embedded system associated with IoT will give a lot of advantages. Then localization, user interfaces. So these are all the very basic steps which are there in the IoT system to proceed to implement this IoT technology. And we have this I'm trying to change the slide. Yes. And basically, the four major parts are there to implement this IoT as well as to understand the IoT. First of all, we have this RFID, that means radio frequency identification. What it will do, it will identify and track the data of things actually, because the data handling is very important. So we have to identify as well as track the data of things very clearly. First one. Then followed by sensors actually. So what the sensor will do basically, we have different types of sensors. The sense we have different types of sensors like application where we are using like temperature sensors as well as IR sensors like that, right? So what it will do, it will collect and process the data to detect the changes in the physical status of the things. Basically, the sensor we have to implement. For example, when we are implementing this smart grid application, so our smart car applications, we have the sensors there. What it will do, it will measure the temperature as well as it will measure the any discomfort will happening in the car, as well as it will measure the speed range, as well as it will measure any disturbances coming. So there the sensors play a major role. What it will do, it will collect and process the data to proceed further. So sensors plays a major role. Then we have this smart technology. Yes, along with the sensors, we have to use a smart technology. That means enhancing this power as well as some electronic accessories to make this IoT very fruitful way. That means what this smart technology will do, it will enhance the power of the network by developing and processing the capabilities to different part of the network. Because the IoT, if you speak very clearly, it's a big network actually because it's all interconnected, right? So from one part to the different part of the network, we have to use this smart technology along with the use of the sensors. That's what the smart technology plays a major role. Then we have the nanotechnology. That means to make the smaller and the smaller things have the ability to connect the internet. Because to connect the internet, to make the smaller and very small things have the ability to connect and interact. That's also very important. Basically, IoT works basic on these four things. That is RFID. What it will do, it will identify and track the things. Then sensors, it will play a major role. It will collect the data and process the data. Then the smart technology, it will enhance the power to the network by developing processing capabilities to different part of the network. Then we have this nanotechnology, small things which have ability to connect the internet. That's the basic things happening in the network. And then uh, the structure of IoT. Basically, after this understanding this earlier slide, how the IoT works, the structure of the IoT. Actually, the IoT comprise things that have very unique identifiers, okay, that are connected to the internet. What it will do, that means it allows the things to communicate and exchange the data, of course, as well as it focus in the configuration as well as control and networking via the internet of the device, such as sensors as well as some control circuits, etc. So, what is the main structure of this IoT means? So, the IoT basically can be basically viewed as it's a network consisting of various devices and computers connected through some series of standard internet technology. That means RFID sensors, as we discussed, as well as the embedded systems, as well as some nanotechnology. As we seen earlier, first this RFID plays a major role. That means the real-time traceability and addressability of this RFID of the data. Then sensors. The sensors. Sensors. Am I audible? Anyone, please? Madam, am I audible?
Yes, sir.
Yeah, screen is visible, ma'am?
Yes,
because
yes,
here it is raining. Okay, fine. Thank you.
it's fine.
Thank you. So sensors. So as we discussed now, sensors are one of the primary devices to implement this IoT technology. So the researchers who is working in the sensors, they are developing very low cost sensors with more quality to identify the data based on this application where we are using, as well as this, as we discussed, embedded intelligence, because this embedded intelligent technology is used through sensors to perform the connection to the internet, and then the nanotechnology, that means the small things to interact and connect with the internet of things. So these are the very basic structures we are having in this IoT technology. Then the next thing is actually characteristics of this IoT, because before going to applications widely, you have to understand these characteristics. First characteristics, very important characteristics. The IoT is basically a self-adapting as well as self-configuring, that is dynamic and self-adapting and self-configuring. Why? Because the primary activity of this Internet of Things technology, IoT technology, is to collect the data from the environment, right? That's what it is practically doing. And this is achieved with the dynamic changes that take place around the device. Moreover, the device change may become change dynamically now. For example, sometimes it is in off mode or sometimes it is in on mode. So it has to identify the device change, and then it will connect to the devices and locate the system configuration. So the dynamic and self-adapting or self-configuring is a very important characteristics. Dynamics and self-adapting. Then moreover, if you implement this IoT, it allows a large number of devices, not only one or two in the system, large number of devices work together to provide a certain functionality. That's the objective of this implementation IoT. So these devices configure themselves, step into the network, as well as it will detect or fetch the latest software based on the upgrades with the minimum user interface. That means if you speak this IoT as one of the self-configuring, what it will do, it will allow the large number of devices and systems work together to provide certain functionality. Moreover, it will configure themselves, and also it will identify the recent softwares which is used to upgrade themselves with the minimum user interaction. That means all are connected properly to become as a self-configuring thing. Moreover, the third important characteristic is nothing but unique identity. Yes. So each IoT device has a unique identity. Yes. So what it will means, it has unique identifier. So the IoT device interface allows the users to connect the devices as well as monitor the status and control them remotely. The main characters of the unique identity of this IoT device is nothing but it will allow the users to connect as well as the monitor and then control them in the remote place also. Suppose I'm sitting in my home, I can able to see what's happening in my lab. So that means completely controlled with operation, controlled system operation, unique identity. That is one of the important characteristics. Next is interoperable communication protocol. Yes, basically the IoT device have more number of protocol systems because we have TCP, IP, like the different protocols are there. So using these protocols that has to be communicated with each other effectively. That is possible with use this IoT because so that it is called as interoperable communication protocols. Then the fifth characteristics, important characteristics, integrated into information network. Because the IoT devices are integrated into the information network that allows the devices as well the system to communicate and exchange the data with other devices and systems. See, the main motivation of this integrated, that word integrated into the information network in IoT is, okay, the reason is it will communicate and exchange the data with other devices and systems. That's one of the thing. And then next, as usual, we discuss that embedded intelligence. Yes, this is also one of the important characteristics, embedded intelligence, because the embedded systems plays a major role when you are implementing this IoT. So if you look at it as a IoT as in terms of block diagram, we have various parts. That is, first it has very good connectivity. Connectivity is very important. So how it is possible using this USB host we have actually. Moreover, also we have this what is USB Universal Series bus, right? As well as this RJ45 and Ethernet card and all is there. Then another important thing is nothing but we have the processor, that is central processing unit is there, CPU. Then followed by audio and video interfaces also there, so that it will monitor what's happening the system data and all. That is high definition multimedia system. Then the multimedia interface, that is HDMI is there. And then different memory interfaces also should locate, that is NAND and NOR, as well as this double DDR, double data rate configurations also there. Then the graphics we have that is the graphics processing unit GPU. Moreover, the storage interfaces in the sense we have this SD card, that is a secured especially SDIO, secure digital input output, all those things. Then input output interfaces for sensors and actuators. Also there, that is example this UART. What is UART? Universal Asynchronous Receiver Transmitter. Then SPI, series peripheral interfaces. Then CAN, controller area network. You can see in this block diagram, The IoT has various subparts. That is, it has connectivity, processors, graphics card, as well as memory interfaces, storage interfaces, then input output interfaces. So all those things working effectively uh, to implement any applications, right? And then if you basically the IoT devices, whatever is there in the block diagram, what it will do means it will, as I said, exchange the data with other connected devices and applications, either in direct form or indirect form. That is one of the first things. Then collect the data from other devices and process the data locally, remotely. Then what it will do? It will send the data to the centralized servers. It will send the data to the centralized servers, either in the cloud-based application for other kind of application for processing the data. Then the fourth one, this block diagram from these various different components are there. Fourth one, it will perform some tasks remotely and other tasks with the IoT infrastructure. Basically, it will exchange the data, collect the data, then process the data with using the cloud application, then perform it according to the application what we are using. So it's one of the important thing. And then basically we are classifying this block diagram into another perspective, that is called as interfaces as well as sensors. Because the interfaces side we have input output interfaces as well as interfaces for internet connectivity, then memory and storage interfaces, as we see in the previous slide, then audio video interfaces. On the sensor side, we have temperature sensor, pressure sensor, ultrasonic sensor, as well as there is IR sensors, all those, that is infrared sensors, all those things. So it's all connectively working to achieve the IoT application. And protocols, as I said, protocols also very important. We have this TCP as well as IP and other kind of protocols like application layer as well as the network layer, transparent layer, all those things, right? So then if you talk about this Internet of Things, actually the IoT is a network of network actually, because let me go to the slide. It's a network of network, because we have various areas. For example, we have education, we have transport, we have home application, we have business application, we have even the energy as well as earth, all those things. So if you treat everything as a one of the network, but all interconnected to other network. For example, if you take transport, energy as individual network, then there's all interconnected together. That is possible with the application of IoT. Okay, with the security as well as more we can analyze as well as it will give a lot of advantages. What are the advantages it will provide? It will increase efficiency as well as it will increase efficiency, and more data can be handled successfully. That's that it's happening with this IoT as a network of network. Okay, for example, if I have this energy means we have one side we have smart grid, and another side we have transport. Example, electric vehicle. If we take, how can we implement the smart grid concept with respect to the electric vehicle as a transport? Okay, so smart grid energy is one of the network, and electric vehicle is one of the network. So how it can be merged together? Yes, if you have electric vehicle, we have to charge the battery. So if you want to charge the battery, we have to use this solar photovoltaic based, renewable based power generation. That means that is located in one of the charging station. We used to say charging stations. So if I'm traveling the electric vehicle and I have a battery, suppose the battery is going to get empty, I have to replace the battery. So I'll go to the nearby charging station, and the time takes time because I'm going for the slow charging. So I'll be taking the one of the battery already fully charged. By the way, I'm giving my old battery to the shop person, and I'll go, continue my traveling, and also I can monitor. That is up to what time my previous old battery is getting charged. That means this one network can be interconnected to another network using this Internet of Things. For that, the basic things what we discussed earlier: sensors, actuators, embedded things. All those things are very important, please. Because in the future, data is one of the major concerns. That means various applications we are using, right? So is how this data can be effectively controlled as well as connected. That is possible with this IoT, because every network having a lot of huge data, It's all controlled effectively by this IoT. That also it's create a lot of job opportunities. For example, energy system side we have mechanical electric engineers, and transportation we have mechanical electric engineers. Similarly, you can also take in the business side as well as the other kind of application computer science engineers. So the IoT is not limited for the particular one field. It will cover all the engineering domains to create the job opportunities as well as to provide the best solutions. Okay, that's what I'm trying to say in this IoT as a network of network. It's all interconnected. And another important point is what will happen if you use this IoT, that is Internet of Things in the future application. Lot of money will be saved once we implement this Internet of Things. That is connected machines, and the data can be effectively handled. Means what it will do, it will save a lot of money. For example, we have very important areas: aviation, then power, healthcare, and rail, that is railway, as well as oil and gas. These are the very major area for the any country. So in the here, if you implement this IoT, that will going to give a lot of savings. Example, aviation, that will give fuel savings. It's one of the simple side actually. Power, it will say also fuel savings. Healthcare, reduce the system inefficiency, and also railway, it will reduction in the inefficiency. The oil and gas, reduction capital expenditure, all those things. Based on that, a lot of money is savings. One of the survey it is telling. So we have to think about this: how this IoT will play a major role, in the future to connect the machines, connect the machines. So the value of industrial things, industrial internet is very huge. That's what you have to understand this IoT. As we are discussing that in future perspective, we are going to have this smart grid as a one side, as well as the another side we have this smart factory, and here we have this hospitalization. So we used to say smart hospital, as well as to handling the things which is connected with the railway as well as the other kind of transportation. We used to say that is called as smart transportation. So once how we are going to interconnect, because all are practically connected. Because once you want to implement this thermal power station, we have to take the coal from through railway tracks, right? Similarly, if you want to take any supply, any things which are required for the industry, that has to transport from various transportation mechanism. Similarly, for hospital, that has to be every time should be powered. For that, we have to get the continuous power supply. So you see, all are interconnected. How we are going to this making this interconnection through the use of this IoT? That's what we have to think about. That it will create a lot of job opportunities. If you take this smart grid that is going to produce a smart power system, followed by another side, we have this smart hospital. So how this hospital optimization as well as the intelligent medical devices can be services can be taking place. And similarly, if you take into the transportation, the shipment, how it's going to take place. Similarly, in the case of industry, how this industry optimization is going to take place. Then how this logistics optimization take place. If you, it's all connected and effectively controlled in the smart way if you use this IoT. Especially, I'm basically from the electrical engineering background. We are working this smart grid as well as smart power system. So we are trying to develop various smart power system, including the DC micro system or the AC micro system. Because of using this DC micro system, we have this using of the solar PV, solar power plant, like that. So once we implement this kind of this smart power system, we'll see a lot of advantages. What the advantages means, I used to see in our projects and all. Efficiency improvement as well as the cost reduction, and then the controllability as well as the no power theft and all, and the overall controlling of the entire system will be improved, and it can be give a lot of advantages once we implement this smart power system. For that, the Internet of Things is very much required. That's what then what is the technology roadmap? Actually, from the 2000 onwards, the RFID tags came, right? So from there onwards, now we are increasing up to the 2020 as well as now in the future also 2022, 25 and all. So the Internet of Things plays a major role. That means in the 2020s, before 2010 and all, the demands for logistics can be increased. Further, in 2010 and all, people are looking for the security as well as more surveillance and transportation and food safety, all those things. And after the 2020, recently, so the locating people and everyday objects. That means the ability of the devices located indoor to receive the signals. Then what's happening in the next future as well as the current time means various software agents and advanced sensors are developed. So the physical world, that is the complete system is going to be to monitor as well as control some the distant objectives. So the roadmap for the Internet of Things also increasing very linearly. In future, a lot of changes happen. So for that, the future engineers is going to give solutions to meet this all those challenges and problems. Okay. Now let us come into the application. Basically, the IoT applications is not limited, but in this slide, it has been broadly classified into two ways. One is industrial IoT applications, that is industrial support, industry applications. Another side, we have consumers, the normal consumers applications, that is consumers IoT. If we talk about industry, as we see in the previous slide, smart grid, smart power system. Similarly, smart logistics, because handling the data, similarly handling the various kind of goods is very important. So logistics is there. Then smart transport. Nowadays, electric vehicle started coming. In the future, even another couple of within this 10 years, EV plays a major role. So how it can be implemented as a smart transport system and how it can interconnect to the power systems, all those things. Then smart machines in the industry, then smart factory, smart industry. And another thing is smart agriculture. People are working in the smart agriculture also. Then smart health, that is one other important area. Because of this pandemic situation, we are facing a lot of problems, right? So how this smart health system will be useful for the common people with less cost as well as to get the benefits, more benefits. So they're all coming under the industrial side. And if you go to the consumer side, we have actually smart home, individual smart home, followed by smart cities. Yes, and as well we have actually smart retail, as well as smart mobility. Yes, that is smart mobility means individual electric vehicle. If you take the smart transport, that is a very big network. Smart mobility integrates the electric vehicle. Apart from that, automation is also one of the major part. That is using this IoT, home automation and industrial automation, building automation plays a major role. Right. Then manufacturing area also the IoT is going to give a lot of advantages. Then the medical and healthcare systems. So now we are seeing in the future what will happen. Now we are in a very big pandemic situation. So such kind of problems should not come in the future. So how to avoid that? How to improve our healthcare systems? That is the responsibility of future engineers. So we have to work hard for that. Similarly, media. In the media also the IoT plays a role. Then environmental monitoring. Yes, nowadays another major concern is why we are implementing this electric vehicle and all because of CO2 emission, global warming, all those things, right? So for that, how this IoT will be useful to monitor the environmental conditions. Similarly, infrastructure management, then energy management. Yes, it includes along with the smart grid. Actually, if you talk about this smart power systems, so the energy, how to efficiently manage the energy such that we can save the energy. So for that, the IoT plays a major role. So the application is not limited. See, all the areas IoT has covered, including the electrical side, mechanical side, computer science, including the civil engineering, like building, automation, like that. We have to learn the technologies. Using the recent technologies, how the IoT used to implement such kind of areas, and it will be useful for the society, right? Ultimately, whatever the implementation we are doing with this IoT, that should be useful for the society. A few examples are shown here. Applications. See, we have this first of all home. It's called as consumers IoT. Then we have the transport mobility. We can say as a industrial. Then we have health monitoring system. We have the buildings as well as we have the industry. So it's all covered. Whatever it's starting from home to industry, it's all covered. But what's happening here? How to use this IoT actually? In the home, we have actually various kind of light loads. Then irrigation controller. Then smoke alarm. Refrigerator. Similarly, stove as well as energy monitoring. In this area, we can implement this IoT. Smart IoT-based refrigerator is there. Similarly, IoT-based washer and dryer system is there. Then IoT-based energy monitoring system. In our individual house itself, we can see, we can control, we can easily able to see how this energy, whatever, how your various loads are, the energy can be diverted and how it can be controlled, saved effectively. Then the transportation, traffic system, then telemetrics as well as packaging and monitoring. Similarly, the supply chain, shipping, another on the public transport, airlines, trains, everywhere. we can able to see this implementation of IoT in transportation. Then health monitoring system, yes, it's one of the important area nowadays. Example, there is equipment monitoring and hospital management and remote diagnosing and patient care. Here we can see the implementation of this Internet of Technology. Then building infrastructure. So HVAC security as well as lighting system, electrical. The building infrastructure means how the electrically the building can be controlled. Then the lightning, entire the light load of the building can be controlled. Then the emerging elements can be controlled. Similarly, this structural integrity, how the structural integrity of the building can be monitored. There IoT can be useful. And another say last side we have actually industry. Yes, here electrical power distribution is an important thing. Then the maintenance, similarly surveillance, then smart grid, as well as other kind of waste management. Yes, waste management is in this also the IoT plays a major role. Yes, of course, just keep on continuing. Another example, the application of this IoT in the case of waste management system. How because in the cities we have very good infrastructure with access to energy sources and long range data communication will be there. But how it can be controlled effectively to take care. In this side we have actually various kind of industries and all, and how this waste management can be taken care by using this IoT. So for that, huge data will be there. So cloud platform that will support and sensing as a device is also take place in the case of using this IoT. So what are the benefits actually? What are the benefits of this IoT in this sense means? IoT basically, if you use this IoT technology, that will monitor the overall business of this process. Now you take any area in the case of power or hospital management or smart grid, transportation, and the civil engineering area, that will increase the overall business of the system. Moreover, the IoT improves the customer experience actually. Yes, and also it will save a lot of time and money, right? Because we can easily control the things, so our time will be saved as well as the unnecessary wastage will be avoided. That's what it will save the money also, especially in the case of energy. The unnecessary energy will be controlled such that efficiency can be improved. Moreover, the money can be saved and enhance employee productivity. Yes, and also it will integrate and adapt the business models. Yes, that is also a very important thing. Various business models are there, so that can integrated and very easily adaptable if you use the IoT and make better business decisions in future. We have to see what kind of the business implemented based on situation. So there, this IoT plays a major role and generate more revenue. Of course, once we implement this, when the loss reduces, definitely we'll be getting more benefit automatically. The revenue will be generated once we implement this IoT. Okay. Similarly, once you and the industrial IoT, yes, the industrial IoT is the another important thing. It's also called as IIoT because what is the difference between the conventional IoT, Internet of Things, and especially we are going to use the Internet of Things means because this industrial IoT is mainly focused on the industrial, that is digitally connected industries. Okay, and so for example, I have in my state, I have some major power plants, power generation stations. Either we have the coal-based power station or renewable-based power station. Once it is controlled digitally, now it is already controlled, but since effectively controlled by using IoT, it has a lot of advantages. That means we can easily monitor the power diversity throughout the states. So the digital connected factory is one of the main focus in this industrial IoT. Followed by facility management is also another important area in the case of industrial IoT. What I'm trying to say, if you take this digital connected factory in the first case, so what the IoT will do? IoT enable the machinery and can transmit the operation information to the partners, like original equipments and manufacturers to and also the field engineers to nearby industries. So all internally connected, digitally connected. That's the reason that if you take the facility management means the use of IoT sensors in manufacturing equipment, so that will enable the condition based the maintenance alerts. All those things will happen. If you take this production monitoring, it's also called as production flow monitoring. So the IoT in the manufacturing can enable the monitoring of production, and also it will refining the process and to implement the production, to increase the production. So production monitoring area also the IoT can be implemented. And then the inventory management, then safety and security. Yes, the industry safety and security is another major point. So the IoT combined with the big data analytics and big data that can improve the overall worker safety and security of this industry. So safety and security also the IoT plays a major role. Then quality control, yes, that means the quality control means the IoT sensors collect a lot of data, right? So the IoT sensors collect and collect the data to the and then it will give to the other third party system. So from there it will make the systems very quality. So that's called as quality control is also possible once you implement this IoT. Then logistics and supply chain management. Similarly, the packing optimization by using these IoT sensors. Uh, the packaging of the manufacturers can give more insight into the use of patterns and handling the product from the multiple customers. So using this IoT, the multiple customers and packaging optimization is also achievable. That's what the industrial IoT, IIoT is another area that's mainly focused on this industry side. Okay. Then what are the technical challenges are there? As we are talking about this IoT, but various challenges are there. Since the future engineers we are going to work in this IoT, we should know what are the various technical challenges are there in IoT. The first one is the scalability. That means scalability in the sense how the IoT can be implemented to the systems and how that can be effectively controlled to the various parameters. Then the technological standardization. Actually, once we implement the new technology, the standards has to be followed very clearly. So the technological standardization is very important. Then interoperability, because various devices are connected, right? Various devices are connected through internet. So the interoperability should be monitored. Then the discovery. Similarly, the software. Yes, we have to upgrade the softwares effectively. So the software complexity is also another important challenge. We have to work on that. Then the data. Yes, the data volumes and the interpretation. So much of data are there. How to control the data, how to handle the data. So data handling is also very important. Then power supply. Yes, since the IoT uses a lot of sensors, actuators, and other accessories, other components and devices, power supply, and also the controllable, the entire system, power supply design is also very important. Then the interaction and the short range communication is also one of the important challenges. See, the short range communication means if you implement the IoT for the smart electric vehicle system, that has to respond immediately whenever the problem is facing by the vehicle. So the short range communication interaction is very important. Then the next one is wireless communication. Yes, nowadays, in example, in the case of electric vehicle, we are trying to hear the word called as wireless charging. So yes, once you implement such kind of wireless charging, that too wireless charging with fast charging mode, how to implement that? For that, a lot of challenges are there in the case of wireless communication, all those things. Then the fault tolerance. Yes, so how we have to find out the solution for this and meet these challenges, starting from scalability to the future fault tolerance, right? Okay, and now let me go to the application once again. Actually, I just discussed only 2 slides. If you take into the application example, if you take home, if you take individual home, we have smart lighting system as well as we have smart appliances and smart smoke detectors, all those things. Or if you come into the retail area, we have a smart payment. Yes, there IoT plays a major role. Then the smart vending machines. Similarly, smart inventory management. Why I'm using the smart means because of it is effectively giving the output. Similarly, cities, that means smart parking system. There IoT plays a major role. Smart parking. Similarly, smart lighting, smart road. Yes. Then logistic. Then environment means weather monitoring. Yes. Similarly, and also air and noise pollution, global warming conditions, CO2 pollution to monitor all those things. Then the forest fire detection. Sometimes we used to see fire happening in the forest, right? So the forest fire detection, there IoT will be useful. Then the energy system, that's what we used to say, smart grid. Then the industry means machines. Similarly, the quality and output, all those things. Then agriculture, that is very important part. That is especially smart irrigation system. Smart irrigation systems, one of the major area in the agriculture, how to implement using this IoT. Then health, that is health monitoring system. Similarly, with the fitness monitoring and the wearable electronics, all those things. So these are the various applications of this IoT. It's not limited. Still, a lot of applications are there, and how we are taking and working further to implement this IoT. Okay, and also what is the um, uh, what we have to do in future to go with this IoT means, first of all, consumer education is very important. Everybody should know implementation IoT, what will happen, what is the advantage, all those things. Then the product reviews and comparisons is must. Similarly, the voluntary discourses and the voluntary market should be there. Then self-clarification and the voluntary codes of practice. Similarly, the trust marks and Internet of Society should be there. Then the government initiative should be there. Like now, government is working with electric vehicle, right? Similarly, government is working with renewable energy, right? Similarly, in future also, the Internet of Things, government will start move. So you can smartly control your system. It's called a smart grid, smart vehicle, smart transport, smart health system, like that. So government initiatives will be there in future, and security requirements should be there. Yes, that is also another important point. Then the certification, whatever the IoT things we are applying, that should be properly certified with the authority. Similarly, the liability reform, all those things are the future things we require to implement this IoT, right? Okay, then what I will do, I just conclude this presentation. I just only discuss the basics of this IoT, structure of the IoT, followed by the characteristics of the IoT. What are the characteristics? Means self-adapting, self-configuring, as well as the unique identity, then the interoperable communication protocol, then embedded system, then integrated information network. So all very basic characteristics. Then the industry and the future perspective of IoT has been discussed. Then the main block diagram. The block diagram we have seen connectivity, processor, and audio video interfaces, then input output interfaces, then memory devices, similarly storage interfaces, all those things that are also discussed. Then various applications in the field of industry and consumers are discussed. Similarly, the advantage of implementing industrial IoT, IIoT discussed. Various advantages are there, right? Starting from digitally connected factory, then factory management, similarly inventory management, and plant safety and security, quality control. That all those things discussed. Maybe in the next section tomorrow, they will be covering the application itself, how to implement practically using some simulation softwares. So that will be covered. Example, either smart grid system, or smart transportation electric vehicle system using IoT. How it can be controlled will be discussed in this tomorrow's presentation. Okay. With this, I will be concluding my presentation. Now we'll go for this question and answers. I request participants can ask the question and answer. Yeah. Thank you for your patience and listening this lecture. Tomorrow, and after tomorrow, 2 more sessions are there. So there you will be learning more practical applications of this IoT using some simulation softwares, right? Thank you. Madam?
Yes, sir. Sir, you can just check the chat. Sir, can you hear me?
Yeah, ma'am. Now, yeah, I can hear you, ma'am. So, how can I answer this question, ma'am? Students will unmute and they will. I can read from the chat box.
You can
answer box.
You can just read from the chat box. Students,
chat box only, na?
Write in the chat box, or if you want to speak, do raise your hands.
Okay, fine. So one student asked what is TCP and IP. Actually, this is the protocol systems that has to be followed once we implement in this IoT and all. TCP indicates that one second, where we are now. IP indicates that internet protocol. IP indicates internet protocol, and TCP indicates the transmission control protocol. These are all the protocols we need to follow once we implement this kind of Internet of Things applications. Then one more student asked that why IoT considered separately? IIoT, yes, very important question, because the industry plays a major role for the country's development, right? So the implementation of the IoT as well as adaptability of IoT will be different from the normal conventional our home applications as well as our consumer application. That's what this IIoT, industrial IIoT has been considered separately, because there most of the industries can be connected together in the digital form, as well as that the quality can be controlled effectively, as well as the security and safety can be enhanced effectively once we have this IIoT separately. So the productivity will be increased. That's the reason that we'll be moving this IIoT separately. So it's already people are working on that, how it is possible practically, because connected in the various industries through one platform, because handling data is very important, right? So how it can be digitally connected and controlled through IIoT is under research. People are working on that. Okay, so IIoT, that's what it is considered separately compared to consumer IIoT. Then is in Amrita is enabled. Yeah, we have very good laboratory models are connected with this IoT application. Moreover, we have separate IoT lab actually that is supported by uh, IoT lab that is supported by various industry like Intel and all. They are very big. You know that Intel is one of them, very reputed industry. So under their support as well as our institute, we have separate IoT AI lab. There a lot of products have been developed. Yes, in our Chennai campus. Right. Next is why IoT needs a GPU? Yes, graphical based, because sometimes what is GPU? Basically, graphics processing unit, right? So in the IoT, since all the devices are connected, as well as it is implementing the process in various levels, it has to support for this the graphics the processing unit is also very important. Otherwise, the speed as well as the quality will not be achieved. So that this GPU will be used in the case of IoT system. The next one, are servers a part of IoT, sir? Actually, we can do actually the server that concept is different. Okay, server concept is different, but IoT is different. That depends upon how you are controlling the servers also using the IoT. I don't want to tell this implementation server and IoT as a unique. Both are having different idea, but we can use also to control the server if you we know some very good programming and all. What is protocol, sir? Yes, protocol means once you implement this kind of technology, that has to implement through proper mechanism. That's what in earliest time itself we started using this protocol system. That is Internet Protocol and TCP, all those things. So it's a basic things to implement a system called as a, then only that will be executed accurately. Example, the transmission control protocol and internet protocol, all those things. Okay. So protocol is very important once you implement this IoT. Then is IoT the basis for AI? Good question. AI is one of the major area. Okay, IoT is one of the separate major area. You can use this AI in the IoT applications also. Okay, for example, we are going to control the electric vehicle using Internet of Things. So there, you can use the AI technology. We are going to control the smart power system using IoT. We are going to control the smart load. Example, refrigerator, something like that means IoT. But there, to control the using IoT, you can use this AI algorithm, AI techniques. So it's not basis, but we have to learn separately as a AI technology as well as IoT technology, and how both can be used for the application is very important. Okay, so AI you can work along with this IoT to effectively use the any system. Okay, that's what the AI can be used, right? Then uh, any other question from student side? Please, any other question from student side? Is the yes, I answered for this. Is IoT is the basis for AI also? Any other question? Students has raised the hand earlier. I seen.
One
Please, any
student
question you can.
answer. I will
Yes,
just.
ma'am. Yeah.
See, you can talk now. You can unmute and talk now.
Hello, sir.
Yes. Yes. Please proceed. What's your
Sir,
name?
I got in entrance exam phase 2 121 marks. Sir. Can I get seat in Amrita?
Students,
You will apply.
yeah, please don't ask admission related queries here. Please ask the queries related to the topics sir have taught now.
Okay, sir.
Yeah. You can ask the whatever the topics we discussed today. Then next question has to be Varun Sai. Is hacking is linking with AI? See, I used to say AI is one of the very important technology. Various algorithms and methods are there. We can use also, but we'll use this AI as well as this machine learning algorithms and technology and all for various applications. We no need to focus only on this hacking and all. I say generally, it's one of the important emerging technology and methods used for all the applications. Okay. I'm not focusing only on hacking and all. Yes, I'm suggesting students to learn this AI and machine learning algorithms to improve the career as well as to get the job opportunities, right? Good.
So yeah, I have
Question?
you can just unmute and speak.
Good evening, sir.
Good evening.
Sir, I have a doubt, sir. Sir, how will the data
Yes,
transfer
sir.
from the sensors to the CPU, sir?
How the data transferred from sensors to?
To the CPU.
Yeah, actually, yes. See, we have this. Yes, I'll tell you. Basically, in this CPU, we have this. Basically, what is CPU? Central processing unit is there, right? And we have this data from the sensors are there. So there various interfacing cards are there, right? You know that is connected with various interfacing systems. One side we have this memory interfaces, another side we have storage interfaces as well as connectivity for USB, all those things. So through that the data can be transferred from sensors to the processing. Example, that has to lot of connectivity cables are there. It's also called as series bus ports are there. Through that that has been transferred from your sensors to processing. But ultimate point is nowadays the research is going for if you implement IoT, what kind of sensor and how the sensor can be effectively optimized and controlled. That's also another important area. Okay, then the processing phases will take place.
Sir, can it be done in long range also, sir?
Please, can you repeat once again?
Sir, can it be done in long range also? That is in a very high distance from the sensors and the CPU. From a long
Yeah, we
distance,
can,
it be
but
transferred?
yes, that depends upon if you take the long distance, if you take that depends upon the the quality of the sensors what you are using as well as the processing and all those things. Okay, so that has to be effectively designed, then it can be implemented. If you take very low quality of sensors, then it is not possible. That means we have to design accordingly. Then the data can be transferred even the long distance also.
Okay, sir. Thank you, sir.
Yeah, thank you. Yes, any questions from student side?
Students, all the previous sessions recordings are already uploaded. The future sessions, the next few sessions and today's session will be uploaded within 2 days.
Any question from student side?
So that's all I think, sir. Students, if you have any more
Yes, ma'am.
questions, you can mail us to workshops@cb.amrita.edu. And make sure that before leaving the session, you all fill the attendance sheet. Thank you so much, sir. Thank you for a wonderful session. Thank you all students for staying. We'll see you all tomorrow. The session will be at same time. You can all join using the same link. Thank you, sir. Sir, shall I end the session now?
Yes, ma'am. Yes, ma'am. Yeah. Thank you, students, for joining this today's section, and thank you for patience for listening this lecture. I hope today you got some idea about this IoT as well as its application, and thank you.